Okay, so in this exercise, we're going to be looking at reading from a file, which is extremely easy in Python. So to read from a text file, we can simply open it up using the open function and then treat each line of text as a particular sequence. Right? So we can, just like we can loop through a string and access every single character, we can loop through a range and access every number, we can loop through an input file and access individually each line of text as a string. And then to do anything, if we want to interpret that line of text as a number, we need to convert it into a numeric value. So we're going to start real simple here. We're just going to use a data file, and I've posted it with the exercise. It's just simply a bunch of numbers one on each line. Makes it really easy to process this input file. And I'm going to process it, and this could represent anything. I'm sort of pretending that it represents temperature values. So we're going to open the file, and we're going to report back the min, max, and the average temperature found in that data file. I'm actually going to do this program in two different ways. One is sort of a more traditional approach where we individually loop through and we find the minimum max ourselves. And then I'll show you some of the functions available in Python and a little bit of advanced stuff dealing with list comprehensions that can do it without or a little bit differently. The first solution that we do is again, it's important that you kind of grasp how we're accomplishing it. The second solution that I show you is more how the experienced Python developer would do it using some of the features that are built into the Python language that are perhaps not in another language. Okay, so my first step is really to make sure that I can actually open the file. So I've saved the file to my directory. So if I do an ls here, I can see that right next to my source code file, I have the data.txt. And if I take a look at that, I can confirm that everything's there. What I want to do is first, before I worry about min and max, I'm going to actually write the program so it can print out these values, just so I can confirm that I can see them all. So in Python, we can get a representation of a file by calling the open command, followed by the file name. And in this case, I'm going to open it up in read mode. So this open command, you don't want to think about it necessarily of returning a file per se, but it's returning an object. It's returning a thing. We're going to talk a lot more about objects later on in this class, but it's returning an object that represents a sequence of lines. So I can iterate through them. So I can say each line is a temperature, so I'll call it temp. Each line is a temperature, and I can iterate through by calling for temp in input file. And let's just print out temp for now. Whenever I use a file, when I'm done working with it, I want to always make sure I close it. Right, and we can run this, and we should actually get the exact same thing as I got with my more commands. Although I actually, I do see an end of line, right, an extra end of line. And as I alluded to in the modules, the lectures, the input file is returning a bunch of lines. They have new line characters at the end of them already. So when I print and I automatically add a new line, I get that extra space. I'm not going to end up printing this stuff anyway, so I'm not going to worry too much about it. But if I wanted to remove that, I could just not print out an end of line, an additional end of line, and now I got my sequence. Okay, so I can first start out by just computing the average. That's a really simple task. It's a standard accumulation problem. I'm going to initialize two variables. And in fact, later on, again, we'll see how we can do this in a little bit with a little less variables. But right now, we'll keep it pretty simple. Each time I see a value, I'm going to do total plus equals temp. All right, so I'm going to add temp to total. And I'm going to do count plus equals 1, meaning I've seen another value. At the end, I can print average temperature and do count. Right, So if I run that, I'm going to get an error, and it's going to say, okay, well, total plus equals temp. That's an unsupported operand. Ints and strings, right? I'm mixing ints and strings. And remember, I said that the input file is going to return a list of strings representing each line in the file. So temp actually really isn't a string itself, or isn't a float. It's a string. I can change it, right? So I'll do temp equals float temp. And now I've got the temp variable overwritten, and I'll of course reuse it, but it's as a floating point value. All right, and so now I've got my temperature, my average temperature. Now I want to think about, well, how do I find the min and the max? And so let's just think about this a bit. Let me rewind from what I had before in the last exercise. And imagine we're seeing a list of numbers. Right, and so that's our list. If we're going to look at a sequence of values, and we're only looking at one number at a time, of course, the easiest way to figure out the min and the max is to start with sort of, separate variables, right? And start looking at every single number and determine whether or not it's our new maximum or our new minimum. And so in the beginning, the first number is certainly, if this was the only number we had, this would be the min and the max, right? So the first number is definitely going to go into these variables. As I proceed to the second number, I'm going to take that number and I'm going to compare it with max and see that, yeah, this is bigger than the current max, and so I'll override it. I'm also going to take that number and compare it against min, but of course that's not less than 5. When I look at 3, I'm going to look at max. It's not greater than 8, so I'll ignore it, but it is less than min, so I'll change this to 3. The 7 is not greater than max, and it's also not less than min. 9 is greater than max, but it's not less than min. And 6 is less than max and greater than min. And so in the end, I'd have a maximum of 9 and a minimum value of 3. And so this is sort of that sequential way of figuring out what a min value is. Now the only trick is if I rewind here, was that first step. How did I make sure that the first step set the max and the min? There's a lot of different ways I can figure this out. I can ensure that I know whether I'm on my first line and automatically do that, or I can sort of smartly initialize this stuff such that whatever the first value is always bigger than the max and it's always smaller than the min. And a good way of doing this is to just do negative infinity and positive infinity. Minimum will be initialized to a positive infinite value, meaning the first number will definitely be less than it. Maximum will be initialized to a negative infinity value, which means the first number has got to be greater than it. If I initialize them that way, then I don't need to worry about thinking about this as a special case, which is nice. I don't like special cases in our code. So I'm going to say maximum equals float negative INF, and we've seen this before of being able to create in the negative and positive infinity from a string. Okay, and now I've got those values. Inside my loop, after I convert it to a double or a float, I'm going to say if temp is currently greater than my current maximum, then maximum equals temp. I'm also going to look at if temp is greater than minimum, then minimum equals temp. And again, since minimum and maximum start out at these opposite extremes, whatever temp is the first time around, it's definitely going to be greater than negative infinity. Whatever temp is the first time around this loop, it's definitely going to be less than positive infinity. And then from there, everything's initialized. And I'm just going to print out those values. And let's give this a look. Okay, so I get 3 and 93, and if I look at that, 93 was the largest number, 3 was the min, so that's good. Okay, so this is sort of the traditional way, and this is a really good practice problem to kind of see whether you can work yourself through this. It's using a very common pattern where we keep some state variables and we sequence through a list, updating potentially our state maximum and minimum on each iteration through the loop. But realistically, and this is the source code that I'm going to post for the solution for this, but in reality, a more experienced Python developer will recognize that actually there's some built-in functionality in the language can already do this. And in chapter 5.2.2, we're going to look at list comprehensions. We haven't really talked about it yet, but it's going to be part of this solution. So, if you haven't gone ahead and read chapter 5 yet, kind of take a little bit of this with a grain of salt. If you've looked at this and you're familiar with list comprehensions already, this should make a lot of sense for you. So I'm gonna change this around a bit. I can first off, one of the things that this loop is doing, right, if I take this, each time around this input in this input file, I'm converting every single line of code to a float. But I'm doing it one at a time and I'm not really remembering the whole set. What I could do is I could build a list, right? So temps. And again, we haven't seen list just yet, but this is the syntax that we're going to use for that. And we could do a list.append. And at that point, we'd have a list, a complete set of all of the temperatures found in the input file. But it turns out that in Python we can shorten this up and actually write this as a list comprehension. So we can say float x for x in input file. Okay? So it's kind of a funky syntax, but what it's saying is that for every x in input file, convert it to a float and add it into temps. At this point, I can start to take advantage of a lot of nice features of Python lists like the max function. And the minimum function. And the sum. And the count, which is just the length. That's not something I could do without first turning this list into numerics. So the list comprehension part is a really critical part of that solution. At this point, I don't need any of this stuff. Right? I've calculated everything directly. I'll get the same exact answer. Okay. So while this is sort of the more advanced approach, maybe when you start to look at chapter 5, you can come back to exercise 16 and see that final solution that I arrived at in this video. But for now, the initial approach where we just sort of incrementally calculated the min and max is certainly sufficient.